Hi everybody and welcome to a new video in the Deep Learning for Audio with Python series. This time we're going to build a neural network using TensorFlow. TensorFlow is this amazing deep learning library that's used very much in the industry and also in academia, and it has its own way of building and processing information and neural networks. So obviously we're going to follow that. So what should we do? Well, first thing that we want to do is to build a model. So we need to build the architecture of our network. Then once we have the architecture, we want to compile the model, which basically means passing information like the error function that we want to use or like the optimizer that we want to use in our training process. Then we indeed want to train the model, and then we want to evaluate the model to see how well it's doing. And finally, we want to make some predictions, right? But before we're going to start building the model, we need to have a data set, right? And so for the data set, I'm going to use like something similar, well, actually the same artificial data set that we built in the previous video when we built a neural network completely from scratch in Python. So we want to have a data set that will enable us to train our model to perform an incredibly difficult task, the arithmetic sum. And so for that, we're going to need to build the inputs and the outputs. And we want the inputs to be like this. So we want them to be NumPy arrays, and each sample is going to be given by a couple of values like this. And so these are going to be like our inputs for a sample, and we want to basically add up 0.1 to 0.2 and get the results as 0.3. So basically our input array is going to look something like this, and our output array, as we said, is going to be basically like the sum. So at index 0, like here, for example, if we add up 0.1 and 0.2, we're going to have 0.3. And here we want something like 0.4. Right. So how do we build such a data set? Well, I've already done that in the previous video, so I'm not going to cover that again. But we're basically going to use this couple of lines of code here. Cool. Obviously, to have this working, we need to import a NumPy. So we'll import NumPy as NP. And we also need this random function, which comes from the random module. So we can do from random, import random. And you guys by now should know that this random function just samples of values between 0 and 1, a float. Cool. Okay, but now we have all our inputs, our x's, and our outputs or outcomes, our y's. Right, but it turns out that when you are training a model in machine learning and obviously also deep learning, what you want to do is to split your data set into a training set and a test set. So you're going to train your model on the training set, and then once you're done with that, you're going to use the test set to evaluate how well the model is doing on some data that the neural network has never seen before. And why do we do that? Well, we do that because we want to see whether the neural network has been able to generalize the patterns that it has learned by training on a data set, on the training set. And so in order to do that, we need to evaluate the model on some data that the network has never seen before. So all we need to do here is to split our data set into some training set and a test set. So we could do this from scratch, but there's a very handy function that does this for us. So I don't want to reinvent the wheel here. And that function comes from the scikit-learn library, which is a fundamental library, super important library for traditional machine learning. So let me import that function. So I'll do from scikit-learn dot model selection import, and that's called train test split. So if you don't have scikit-learn installed on your machine, just pip install it. It's going to take you probably 30 seconds or less. Good. So here, what we want to do is to have an X train, an X test, a Y train, and a Y test. And here we're going to call the train test split function, and as arguments we're going to pass in our inputs and outputs, and we are going to specify the test size, and say we pass in 0.3. So basically what we are saying here is that our training set is going to be 30% of our whole data set, of all the samples that we have in our inputs and outputs, right? Cool. And so with this function, basically we're dividing up our data set into a train set and a test set, and we're gonna have both X's and Y's, right? And we can easily access them, right? But I don't like this very much because I want it to be a little bit like more modular. And in order to do that, I can define a function which I'll call generate dataset, and I'll pass in a couple of arguments. So one being number of samples, and the other one being test size. So here we are gonna, this function is gonna return this nice full array, so X train, X test, and Y train, Y test. Good. And so the number of samples here, we specify how many samples we want in our whole data set, and so we should like pass it over here. And the test size, we are gonna pass it over here. Good. So now let's see if this is working. And so we'll just do a if name is equal to main, and then we'll move in here and we'll say generate dataset, and we'll say, yeah, let's just have 10 samples, and let's say that we only want 2 of these samples as part of the test set. Cool. And so here this function is giving us back all of these nice guys over here. And so now let's print a few of this, just like to see whether like this is working. Cool. So we can say the X test, so basically the inputs for the test set, this is equal to, I'll just do like a new line there, and I'll pass in X test. Nice. So here I want to see Y test, and so I'll pass in Y test, and this should work. So let's run this and see if it works. Cool. Yep, and it's working as expected. So over here, so for the X test, we have a 2x2 matrix, and each sample is given by 2 values, which are the values that we want to add up. And for the Y test, we have the outcomes, and this is a 2x1 matrix, as we expect. And this guy, for example, at index 0 is given by the arithmetic sum of these 2 guys here. So yeah, this is working. Great. Okay. So yeah, and we want to comment out like this guys here. And now we are at the point where we start working with TensorFlow. So first of all, what we need to do is just import TensorFlow. So we'll do import TensorFlow as TF. Now, TensorFlow comes in 2 flavors. So one is for CPU and one is for GPU. In this video, I'm using the one for CPU because like the stuff that I'll do, like it's quite cheap computationally, so I don't need to like use the big guns. But if you don't have it installed, you want to install TensorFlow by doing pip install TensorFlow. That way you should be able to install this library. If you want to install like this CPU version, that's like way easier. The GPU one is a little bit trickier, but there's a lot of resources online. So you can just like go like Google them and you'll find that out. Good. Okay, so let's build the model here. So we want a model, which is basically our neural network. And for this, we'll do a TensorFlow.Keras.sequential. Right, so Keras is a high-level library that sits on top of TensorFlow. It uses TensorFlow, but makes TensorFlow code like super easy like to build. And so as you'll see, we can build very complex neural networks with just like a few lines of code. And now we are using sequential because we want a network that's a sequential network. So it has an architecture where basically the input signal is moving from left to right. And specifically, the model that we want is the same that we used in our previous video where we built the same model, the same neural network from scratch. Now, if you want to know like how that's done, just go back and watch my previous video. You should have done this like by now, but you haven't, just go and check that out. But again, what we want is a model where we have an input layer where we have 2 neurons. Then we want a hidden layer with 5 neurons, and finally an output layer with 1 neuron. So let's build this nice network. To do that, we do tf.keras.layers, and the type of layer that we want is a dense layer. And a dense layer is a fully connected layer, which basically connects all the neurons from the previous layer with the current layer. Nice. And so the dense layer has like a few arguments it accepts. So one, which is fundamental, is the number of neurons that we want. So we want 5 neurons. And then given this is the first hidden layer, we want to pass the input dimension here. And so here we are specifying how many neurons we want in the input layer. And this is equal to 2 in our case. And finally, we need to specify which activation function we want to use for this layer. And we are going to use, not surprisingly, the famous sigmoid function that we've used so far. Good. So now let's build the output layer. So the output layer is again a dense layer, but this time it only has 1 neuron. We don't need the input dimension here, but we definitely need the activation, which we want to be a sigmoid function. Good. So with just these few lines of code, we've built our model. Cool. The next thing that we want to do is to compile the model. So we'll do model.compile, and here we need to pass in some important information. So first of all, we want to specify the optimizer. We're going to use stochastic gradient descent that we've seen in the previous video. But for now, like, let's leave this like blank. I'll just like go back in a second to this. And the second thing that we want to pass is the loss function. That so far I've called the error function. So loss and error like are the same thing. Cool. And for the loss, we're going to use MSE, which is the mean squared error. Again, if you want to know more about all of these things, I've covered them both like theoretically and an implementation at any implementation level in the previous videos. Cool. So we were saying we were talking about the optimizer. Cool. So the optimizer is going to be equal to tf.keras.optimizers, and here we want SGD, which is our nice stochastic gradient descent optimizer. And here we can pass in the learning rate, and let's say we'll give it a 0.1. Good. So now we've compiled our model. So the next step is to train the model. So, and how do we do that? Well, this is as easy as it can be, really. So we'll do a model dot fit, and here obviously we want to pass in the training set, and so we'll pass in x underscore train, and we'll pass in y underscore train. So we are passing in the inputs and the outputs of the train split. And then we need to pass in the number of epochs. So let's say that we want 100, for example. Cool. And so just doing this, we train our model, and now we should be able to get information when we do this. And let's run all of this code, but before doing that, let's put a variable number here. So for the data set here, let's say we want a data set with 5,000 samples, and we'll do, let's say 30% of that is going to make up the test set. Cool. So now let's run this and see how it goes. We have an error here. Oh yeah, right. Yes, I just forgot a comma over there. That's good. So let's see if it works now. Yeah, it's running. We have another error over here. Oh yeah, I know what's happening here. Cool. Yeah. Cool. So I've never passed the optimizer here. So let's take this optimizer here and pass it to compile over there. Cool. So now, if all is good, we should be able to run this smoothly. Yeah. Finally, it's working. And as you can see, it's training, and it's giving us a report at the end of each epoch. Cool. And here you'll see the loss function, the error. And as you can see, starting from here, it's going down epoch after epoch, which is good, until we get these results for the error after 100 epochs, which is nice. But you should keep in mind that all of this has been done, also the error has been calculated on the training set. But this is not really what we want to do for evaluation. And this is where the test set comes in when we want to evaluate the model. So we'll let's evaluate the model. So let's just write this and say model evaluation con here, and let's just like give it a new line. Cool. So how do we evaluate this? Well, this is like quite straightforward. We just do model.evaluate, and then we pass in this time the X test and the Y test. So here we are basically evaluating the model on the test set, and we are passing both the inputs and the outputs. Now, if we want to see a report here, we should do a verbose equal to 1. Cool. So now let's rerun the script and see whether like this is working correctly. Cool. Yeah. Again, we are getting the training over here, and once this is done, we should see an evaluation. Oh, cool. Over here. Good. Cool. So we have the evaluation, which has been performed on 1500 samples, which is the test set. And the loss function is 7 by 10 to the minus 4. And as you can see here, the loss, the error, is slightly higher than the error that we have on the training set. So the test set is doing a little worse than the training set. And this is okay, because obviously the model has optimized its weights and its parameters on the training set. But at the same time, we don't want to have like a huge difference between the loss on the training and on the test set, because if that was the case, then it would mean that the model hasn't been able to generalize the learning process. So it's not able like to predict things well outside of the data that it has already seen. Cool. So now we are basically done. So the last thing that we want to do is to make predictions, right? And in order to make predictions, we should create some data. So we can just like go back over here and use this, for example. And we'll do an np.array, and we'll pass in like this two like samples here. And we would expect obviously 0.3 and 0.4. And so let's make these predictions. Cool. So we'll do a model dots. Can you guys guess what's going to be the name of the method like for predicting? Yeah, I'm quite sure you had it right, and it's just model.predict, which is super nice and super simple to remember. And then we want to pass in data. Cool. So now let's print and say some predictions over here, and yeah, let's do like a new line, and we want to have a for loop here where we unpack the data and the predictions. And so we'll do for dp in zip, and we'll pass in data, and we'll pass in predictions. And here for each of this, what we want to do is to print. So we want to print that this plus this is equal for our network to like this element here. And so now we want to just pass this values in. So we'll do D0, so D0, then we'll do D1, and finally we'll have a P0. Okay, so this should be right. So let's run this and see the results. Cool. So obviously like it's taking some time for doing like this training, and that's again because I'm running TensorFlow on CPU. If it was like on GPU, it would be like way faster. Cool. So here we have the results. So some predictions. So 0.1 plus 0.2, we are getting this 0.33. Well, I mean, it's not really 0.3, which we would expect, but it's kind of like close to that. And then 0.2 plus 0.2, it gives us like 0.40. Well, it's 42. Well, again, it's close, but not like super close. Well, what this basically is telling us is that we probably don't have like we haven't had like enough data like for like getting like better like precision there. But then again, also we would need to like tweak all the parameters that we have in the network, like the learning rate or the type of loss function that we use, or the architecture itself, so how many layers we have or how many neurons in the layer we have to get like better results. But this is not the point of this video. Here we just wanted to build a neural network with TensorFlow, and that's what we've done. And now guys, you should be super happy because you know now how to build a neural network with TensorFlow. Cool. So what are we going to do next in the next video? Well, in the next video, we're finally at a moment where we can start to look at audio data. And so we'll pre-process audio data so that we will have it in such a way that we then can use it with our deep learning algorithms, which is super nice. Cool. So this was it for this video. I hope you enjoyed it. And if that's the case, please subscribe and hit the notification bell to get more videos. And it would be fantastic if you could leave a like to this video. And I guess if you have any questions, you can just leave them in the comment section below. And I'll see you next time. Cheers.